Hello. In the next 3 videos, we're going to see how we can fit the direction of a character's gaze to the images from the camera. In this part, I will show you how to generate a personalized eye texture that we will use later during the fitting process. To do that, let's first load the images from the top camera. I'm going to drag this file here. And here you can see our image sequence. The next step is to load the camera into the project. To do that, I'm going to use a load camera node. Let's select the calibration file for the top camera. Okay, here you can see our camera. Now we need to undistort it. Let's also undistort our input image. So, this is the image before the undistortion, and this is after. Next, let's load our neutral geometry. I'm going to drag and drop this file here. And then we have our neutral geometry. Next, we need to load an eyeball geometry. I'm going to use the eyeball that comes with our gallery. If we go over here to the gallery and scroll down, you can see this new base mesh. This base mesh comes with an eyeball geometry. In fact, it comes with 2 types of eyeballs, one which includes a sclera, and the second one has a flat iris. The flat iris option is much more suitable when it comes to fitting it to an image, so I suggest always using a flat eyeball geometry for this step. Let me remove the rest of the nodes that we don't need and move the eyeball here. Please note that the eyeball geometry is located at the origin of our scene, which is super important because this origin position is going to be used as the center of rotation for our eyeball. Also note that the eyeball should look in the direction of the Z-axis. Now we need to place the eyeball inside the eye socket. Sort of like this. In practice, this alignment should be done as accurately as possible. I highly suggest you refer to the neutral scan geometry and texture and try to match the eyeball size and position exactly to the shape of the scan. Be especially careful when fitting the eyeball size and try to keep it within a physically plausible range. According to studies, the adult eyeball transverse diameter is approximately 24.2 millimeters and may vary from 21 to 27 millimeters. I've already done this alignment, so what we can do is to reset all the transform values and load my predefined transformation. And here we have our left eye geometry. Let me also load the second transform for the right eye. Alright, for the next step, we need to load the animated facial mesh. I'm going to use a load vertices node and import the results of the guidable replace step. Okay, so here we have our animated face. In the next step, we need to transform the face and the eyeballs so that they exactly match the image from the top camera. To do that, first, I need to load the transformation that will bring my face from a stabilized space to a destabilized space. So I'm going to use a load transform node and import the results of the guidable head stabilization step. These transforms move the model from here to here. But what we need to use is the reverse of this transformation, because we don't need to stabilize the head, but to destabilize it. So I'm going to use the inversion of this transform, and I'm going to rename this node to destabilization. For the next step, I'm going to bring the face from this destabilized space to the camera space. So let me create another load transform node. I'm going to load the transformation from the fact space to the HMC space. There we go. Now we have our face located in front of the camera, and we need to do the same for the left and right eyeballs. Let me copy these nodes and plug in my corresponding geometries there. So here we have the face in the camera space, and now this geometry should perfectly match the camera images. Now that we've done that, we can fit the rotation of the eyeballs to what we see in the camera. To do this, the algorithm will try to match the synthetic render of the eyeballs pixel to pixel with the real image. To make it work, first we need to create a texture for our eyeballs. To do that, I'm going to use an align geom to cameras node. So the first input is going to be our eyeball. Then we need to plug our camera into the third input. Then we need to plug our image into the last input, and we only have two inputs left. One is the point selection on our 3D geometry. Another one is the point selection on the camera image. And using these point correspondences, the algorithm will find the rotation of the 3D eyeball to match that of the 2D image. So first of all, let's create a select points node. I'm going to go here and select the middle of the pupil. And I will plug it in here. Then I'm going to create a select screen points node. And I'm going to plug in my undistorted image here. In this image, I'm going to select the middle of my pupil. But before we do that, we will need to scroll through the sequence and to find a very nice frame where the eye is completely visible. The best frame that I could find was number 170, so let's use this one. Let's go over here and select the pupil's center. I'm going to select this point. Let's plug this selection into the Align Geom to Cameras node. If we hold the mouse over this error sign, you can see an error message saying that we have to provide at least 3 points, but we only have 1. In fact, we need 3 points only if we want to match both the translation and rotation. In our case, the eye is already located at the proper position, so we only need to find the rotation. Let me uncheck the Fit Translation option, and here you can see that our eyeball pretty nicely fits the image. Let me do a little improvement. I'm going to start here and slightly move this point a bit lower, like here. And let's check our result again. To me, it looks better. Now, what we need to do is project this texture through the camera to our eye geometry. To do that, I'm going to use a Project Texture Through Cameras node. The first input is going to be our Align Geometry. The second input is going to be our undistorted camera. Then we need to provide the camera image. And if you go to the 2D viewport, we can see that our texture was projected onto the eyeball, but I would like to only project the sclera and not to project the eyelids. We can do that by using a projection mask, and the projection mask can be automatically generated by facial detection. Let's start with creating a load facial detection node. Let me select the facial detection sequence. We also need to undistort it so that the facial detection matches our synthetic renders. And now we can use a node called detection to mask. And convert our detection into a black and white mask. First, we need to make sure that the resolution of this mask is the same as the input resolution of the image. So I go here and check that my input resolution is 1200 by 1920. And I'm going to use the same resolution here. Then I want to exclude the interior of the lips and the lip masks from our results. Also, I can use this padding parameter to shrink the mask and ensure that the eyelashes are excluded from the projection. Then let's plug in this mask here, and in the visual editor you can see that now only the sclera has been projected onto the eyeball. On the next step, I want to remove these highlights from my eyeball texture. We can do that very simply by creating a small grey image and overlaying it over this highlight. Let's use a Create Image node. Then I can go here and use the Color Pick tool to pick a grey colour from the eyeball, copy, and paste it here. And then I want to set the size of my patch to 75 by 75. And then let's use a Merge Image node to overlay it over the eyeball texture. Now, let's move this texture lower and a little bit to the left. This approach may seem too primitive, but it's good enough for the next step. In order to make the complete texture for the eyeball, we are going to use Angular Image Blur. Let's set the angle to 360. And voila, we have a very nice texture for our eyeball. We can also use an Extrapolate Image node. And now we can apply this texture to our eyeball geometry. There we go. And the last step will be to save this image to a folder. I'm going to save it here and call it Left Eye Projected. So the next step is to repeat these actions for the right eyeball. I'm going to copy these nodes and use Ctrl-Shift-V to paste it, preserving all the input connections. All I need to do is replace my left eyeball geometry with that of the right eyeball. And then here we need to select a corresponding middle point for the right eye. Alright, let's see how it works. You can see that the alignment is pretty good. Then we can go to the projection results, and then we need to adjust the position of our patch. let's move it to the right and also shift it a little bit lower. Alright, let's check the results of the angular blur and also the extrapolation. And there you go, we have nice textures for both eyes. Let's also change the path to the output file. And don't forget to click Compute Current Frame for both nodes. Okay, that's it for this step. In the next step, we'll demonstrate how to find the proper rotations of the eyeballs to match every frame from the camera sequence. Bye bye, and see you in the next video.